Hey, welcome to Web3 Weekly with your host, Blockstar Technology.
Let's go.
Welcome to Web3 Weekly with Blockstars. So this is our episode 2. Today we are talking about everything about blockchain. So let's get into it. So I have Craig on my left.
Hello.
Maureen.
Charlie.
And we have lovely Faizi joining us to talk all about blockchain. So let's get into it, right? So let's first of all, where we start? We start from what is blockchain, right? So what we try to do is when you try to talk about what's blockchain, we want to, as much as it's a technical podcast, we also want to bring in the non-technical people. We had a few chats over this week with people who want to get into the blockchain but don't understand all the technicality of it, and we want to keep it light. It's like saying you're driving your car but you don't have to know how the engine works, you just drive. But we need to have a solid team who knows about the blockchain, about the technology, who can guide everyone into this space. So on that note, what is a blockchain? Blockchain is a non-editable Excel spreadsheet. You can only add, but you can't edit your past. And based on that basic technology, pretty much everything's built on top of that. So whether it's money transactions, or is it like sending an email, for example, whatever a transaction happens, it goes onto a ledger, but you can't undo it. Pretty much it's always moving forward. You cannot go back. There's no undo or edit. So on that note, I'm going to ask a question from you, Faizi, from the technical aspect. Actually, before we go into it, let's tell the audience who we are, right? What do we do at Blockstars, right? So my name is Kosi. I'm the CEO of Blockstars, and Craig.
I'm Craig. I'm a business analyst and part-time Dorothy.
Yep.
And I'm Maureen. I do some business analyst and the in-house counsel work for Blockstars.
And my name's Charlie. I'm operations manager and full-time deacon at Blockstars.
Blockstars, Faizi.
And I'm a smart contract developer, and I also do smart contract audits.
Cool.
I develop pretty much everything. It's like full stack.
Full stack, right? I mean, that's what it's all about, right? It's all about knowing the whole journey from A to Z. So, Faizi, if someone asked you what is blockchain, how would you explain from your side?
I would say it depends on the lens that you bring into this question. For any technical person, blockchain is pretty much like a database that operates much like a database. For a person with a business background, it can be like blockchain can operate like an exchange network where you can exchange value without an intermediary. And if it's a lawyer like our dear Maureen, Maureen might be excited by the potential of the blockchain that removes the trusted entities who are usually required to validate the transactions. So, it's just a broad perspective from different personalities, you can say.
Yeah, that's pretty cool. I mean, I've thought about this one, like it's almost like getting a transparent vault, a safe box, transparent safe box. You write a message, you put it in this transparent box, and you lock it. You take the key and you put another message in the next transparent box with the key, and you lock that. So you can see what the message is inside, but you can't get to it. To get to that first box, you have to open all the other boxes. So it's pretty much undoing all the boxes up,
Yeah.
So blockchain is pretty much.
And the other thing is that it's distributed. So it's not just in one place. The information is stored in different sections and different parts, and everyone has the same copy. So basically a distributed ledger, What were you saying?
Yeah.
Yeah.
So awesome. That's cool. So so we talk about this blockchain, this one big ledger, right? So like everything else, right? There's not only one. There's multiple things, versions of it. So if you talk about what type of different blockchains out there,
Yeah.
Maureen, what do you have to sort of from your side?
Essentially, at this stage, there's about 4 different types of blockchains. So Bitcoin was the first original blockchain, and it's what we call a permissionless blockchain. So it has no central authority. And then since then, we've developed 3 other types of blockchains. So you can have either permissionless, permissioned, or a combination of both of them, which is called hybrid. And then now there's also a consortium. So basically, a public blockchain has got no central authority, right? And so a private blockchain is controlled by one authority, and a hybrid is basically a combination of both. So it has some secure sections and some open. And so a consortium is, sometimes they also call it a federated blockchain, and it's basically got an organization that controls it. So they all obviously have different aspects and elements that make it good, and it really comes down to the essential part, because like these gentlemen have said, is that it's a ledger and it's very transparent. Once anything goes on it, anyone that has access can see that information. So the issue that people have sometimes comes down to privacy and control. So with private blockchains, you might apply it, you might apply it because you want to distribute that information, but you don't want other people outside or just anyone to come along and access it. So you have different options, like what you can keep private, what you can keep open. And does anyone want to add to any of that?
Yeah, I mean, Faizeen, you're the expert when it comes to the blockchain. So.
Yes, actually, it all depends who can, it all depends on who can view the data, add the data, or modify the data.
Yeah.
These are the access rights on which a blockchain is designed, whether it is private, permissionless, public, permissionless, and all those types. It all depends on the access rights and the consensus mechanism, like who gets to validate the data at the end of the day, who gets to update the final state of the data in the blockchain.
So where is this blockchain? Who's hosting that blockchain? Charlie?
No one owns a blockchain, but everyone owns a blockchain. So
I love
it's
that.
distributed. Anyone who wants to run a node on their computer can, and then also that is determined on what blockchain it is. So like Bitcoin or Ethereum, fully permissionless, anyone can join the network, spin up a node, even IPFS, which uses blockchain technology, but not as such as others, but is very interesting. And then there's authority-based blockchains like maybe BNB, where they have 21 authority nodes of trusted people.
What's BNB? Sorry.
Binance Smart Chain.
Binance Smart Chain.
Where they have 21 people validating those nodes with their stake and earning a reward.
So are they there's 21 people, do we know who they are, or?
Yeah, you can see who they are because they release that information.
Yeah.
And then there's also blockchains like old EOS, where the community votes with their tokens into who's going to produce, who's going to be the 21 validators of that network.
Okay, so that's pretty cool. I mean, Faizeen, you touch based on, and also Maureen, you guys touch based on the types of the permissionless. I don't know what do you mean by permission and permissionless when you talk about that? Is it like someone has to give permission to something and other ones just like all in the open? How, so if it's permission, does it mean that someone owns it? And you say like permissionless, that means everyone owns it. How does it break? Can you please break it down for us, Faizeen?
Yeah, just like Charlie said, it all depends on how centralized or decentralized it is.
Yeah.
So in a public or permissionless system, anyone can join in the network. They just have to set up a node and join in the network, and you can even validate the transactions. You don't need anyone's permission to validate the transactions.
Okay.
But in a permission system, it's like a consortium, like group of participants. They join in and they build a network among themselves, and they allow or give permission to people who wants to join in their network.
Okay.
They give them access rights on various levels. And even the certificate, the access certificate or membership certificate, that is also based on .XO9 type of
yes.
certificate. So they are also highly secured.
Yes.
So depending on the membership or their access rights, they have access to different types of activities or functions that they can perform within the network.
And that would be much like a Hyperledger sort of Walmart setup that they're using on their supply chains phasing.
Even the R3 Corda, we have R3 Corda and Hyperledger. They are the most used private and permissioned blockchains.
Okay. So who's behind the Hyperledger blockchain?
It's the Linux Academy, and it's been developed and maintained by IBM. So
okay. So there are some really good backing, like organizations backing this. Okay, cool. So with regards to those ownership of blockchains, I think there are quite a few, right? I think if you talk about the names, what we spoke about was types of blockchains, right? If you talk about names, if I say, okay, like we spoke about Bitcoin and Ethereum, I think with the same thing, right? They're like public. So, and with those things, like for example, now if we are saying Hyperledger, we know about this word called gas, right? So where does gas come from? Crazy.
In Hyperledger?
Yeah. Let's talk about gas in all. Because everyone just say that gas is expensive, right? I feel like sometimes we are talking about petrol.
Maybe it's better just wording it as a transaction fee.
Okay, so that's what it is.
Because Ethereum words it as gas, but
Yes.
you don't have gas in Bitcoin or other certain currencies. So
okay, that's interesting.
The transaction fee.
Okay, so it's pretty much when we say gas, it's pretty much a transaction fee.
Yeah.
Okay, that's cool. So
So in a permission network, you have to incentivize people or miners to validate the transactions in order to obviously add transactions to the validated transactions to the blockchain or participate in the validation.
Yeah.
So, but in private blockchains, you don't need to incentivize anyone. You just build a network among your known participants. You onboard them and give them their duties, responsibilities. But obviously, in the permissionless network like Ethereum, Bitcoin, or any other permissionless network, you need to incentivize the people to come and join the network and validate the transactions. And the more people join the network, the more decentralized it is.
Yeah. So is it because they're adding security, or what is it doing?
Yeah, the more validators you have, the more decentralized it is and the more secure it is. Like there you eliminate the 51% attack, where some miners together get the consensus is more than 51%, and then they get into add bad data into the blockchain.
Well, I mean, so Craig, I mean, like we talk about the 50, Phasing just brought up a really good point, which is the 51% attack, right?
Yeah.
So we had this nodes with 21 validators. So what if like 11 of them got together and say like, oh, you know what, we want to change the course of the transaction? What would happen then?
Well, they could.
They could, right?
It's that simple. That's so. I guess it all comes down then to the use case for each blockchain. So obviously, if you go and start your own, you've got 2 validators.
Yeah.
Well,
you and your man.
You really want 3, so that you at least had
Yes.
a majority vote on what was the current truth on the blockchain.
Yeah.
But yeah, you'd only have to hack 2 systems to do it. So, less than ideal.
Yes.
But it might be perfectly acceptable, even being that small, if it's in a private blockchain that you're using for some commercial or business purpose. Okay?
Yeah.
So obviously, if you've joined together to get a particular task done, then the value is in that, and it's not financial transactions that are necessarily on it. So there isn't that reward or that I guess item of value at the end there that would make it worth your while even doing that. So.
Which was also the reason for the recent Ronin hack, as they only had 12 nodes validating that system. So whoever the hacker was only had to get hold of 6 nodes to control the system and withdraw all those funds.
So I mean, if that network was storing vehicle service data,
Yes.
no one's going to care. As soon as you put financial like value on it, that's when it becomes a target and it's worthwhile. Somebody, attempting the 51% attack. So there are many use cases for blockchain, and the types of blockchains that we discussed currently. Not only are there different types, but then within those use cases, there might be different types within those as well.
Oh, let's talk about those types.
So, they're the same types that we've spoken of, but your public blockchains, for example, so we were talking permissionless, there's many different terms for these, which are generally used for a lot of your cryptocurrencies and things of that nature, and you want people to be able to participate because it's what gives it validity and value.
Of course.
But for those people to participate, there's obviously a barrier to entry, which means that you need to run a node, or and even if that's easy to get hold of, there's the power consumption when we're talking.
Oh, of course, we
proof of
touch
work,
base on that.
We'll get to that, I think.
Yes.
So these people need to be rewarded to participate in the network, hence the gas fees and transaction fees that we were talking about before.
Yes.
To encourage people to do it.
Yes.
You can then get your private networks, which you would certainly want to use for, say, anything medical related.
Yep.
Like, nobody wants their medical records, even if it's not uniquely specifically identified to you. It might be to a unique identifier that's then off chain that they then know is you, like some form of ID. But nobody wants that stuff made public.
Of course.
So, there are very good use cases for private networks. Those private networks can also be used in business or commercial terms if it's within a single company. You might be tracking, locations of items around the country. It's several, you might have 20 depots. So it might all be in one. You can then get that same private network, I guess, but rather than me owning all of those depots, it might be, all right, well, let's take banks, for example. You have multiple banks. It's not one bank that would own a blockchain that the banking system would use.
Yes.
You would have each of the major banks
their
own node,
and
which
the
would
central
then
bank
be
as well.
the consortium or federated type,
that's right.
and that has that use. A lot of the other one we want to talk about is semi-private, and a lot of these will start off possibly as private, and then I believe some of them have use cases where they will go to semi-private. So if we look at that same principle of the private, or it's kind of private because you can control at one point.
Of course,
It's almost a consortium type. So I'm using Walmart as an example here, where they do all of their supply chain tracking on it. So obviously they've got suppliers involved. Those suppliers may be able to write, so it might be semi-permission where they can write some data but not all data. That doesn't necessarily mean that they're a validated node. They could be centrally controlled. But once you get all of that information, and it's great for the corporation itself or the company, but the reason that they could end up being semi-private and act like allowing some of that data to be publicly accessible is to allow the consumers to have complete transparency over where items come from, especially when it comes to food and things of that nature. So you know that it was ethically sourced, that it's been stored safely at a good temperature, and that sort of stuff. And with having that type of information available to the corporation, we've had instances in this country where the needles in strawberries and things of that nature.
Yes.
Right, so they've had to take every strawberry off every shelf because they just don't know.
But things like, so you could have done it in a Web2 world using a database. So why would it make any difference putting on the blockchain?
Because it's immutable.
Yeah.
And that's the big difference.
And
And there's not
Yeah.
one central control. So if who was it? It was Bob at Acme Corp that said Fred provided these strawberries and Barry provided these strawberries.
Yes.
Well, then you're trusting this guy in the middle.
Yeah. True.
Whereas if each of these suppliers are posting their own information and putting it on the blockchain,
Yes.
and it's being validated, then you know that's where it came from. And by being able to track the produce down to that level, rather than have to pull every strawberry,
Yes.
they could check the punnet, trace it back to see where it came from, and know that this issue
Was
be it,
originated from.
it might be at a supplier, at a packaging company, at the farm. You don't know at what point.
Yeah.
But at least they could track it back and know that it's all come through that one point.
Of course.
So if something were tainted, or God forbid, nuts were mixed into something that shouldn't have been.
Yes,
People have
of
some
course.
severe allergies and reactions to that type of stuff.
Yeah.
They don't have to pull every product, so it's not as disruptive to the consumer and massive cost savings
Yeah.
for the corporation.
Okay. So that sounds all good, right? So Faizine, like,
To extend what Craig said,
Yes.
I would like to give an example. When Walmart started their food supply chain on Hyperledger, they first did a POC
yep.
on tracing mangoes
Uh-huh.
from USA and tracing pork from China.
Yes.
So initially, to trace one mango, it took 7 days, 1 week
Yeah.
to on a
On a normal, what do you call the
normal
Web2?
Yeah.
supply chain, yes.
Yeah.
But to trace it on blockchain, it took them only 2 seconds.
Wow.
It's
That's a big
because,
difference.
because everything's that they had to verify rather than having to go through trusting method.
Exactly. They just have to extract the information. That was it. Everything is already there, verified on the blockchain. So
I mean,
that was
it's-
their successful POC, and then they went on to build this Walmart food chain now.
I mean, I hear what you guys are saying, but for me, I'm still thinking like, you know what? Still have it in database, and only one person has access to the database. It's a database administrator. No one else got access, and they can say like,
Okay.
oh, you know what? I want to block everyone from ability to edit the database, and so only the database administrator will have it.
And that's particular type of data. That's a
Yeah.
particular type of blockchain.
Yeah.
But it's when you're closing off that read access to the public that it becomes private or semi-private. Depending. Well, it's semi-private if you are able to write to it or send
Yes.
information. There's, like I said, many
Yes.
different terms. But there will also be instances where you want that data and you want to limit who can write the data,
Yeah.
but still make some of that data publicly available.
Of course.
So if you, and I'll use like a really quick basic example, if there were a group of, I'll go with music festivals
Yeah.
on around
Yeah,
the
yeah.
place, like over a particular week, hell, it could be like Christmas concerts, things of that
Yeah.
nature. And if the ticketing were done on the blockchain, that's great. I don't need to know that you specifically bought a ticket,
Of
and
course.
I'm not the one writing the tickets to the blockchain or
Yeah.
anything of that nature. But making the number of people at any location known.
Yes.
And again, this doesn't even necessarily have to be public. It could be public or it could be
It could be
semi, like,
semi,
you know what I
yeah.
mean? So let's just say Charlie's, the local, he's got the taco truck that he's going to roll up.
Yeah.
It's invaluable information for him to know, the demographic, but also where the people are. It's no good if he's parked 6 blocks down there, but this is where the thing is, this is where most of the people are going to be.
Yeah.
And that type of thing. It's the same for vehicle servicing, which I've touched on previously as well.
Yes.
If you knew how many people were having vehicles serviced at a particular dealer in one day,
Yes.
then Uber knows to have cars available close by, or the taxis, or run a bus. But,
And also when it comes to like fresh produce or fresh fish,
Yeah.
you can scan that QR code and trace
Yeah, that's-
where it's come from,
Yeah.
what date it was
That's
picked,
So I'm saying, yeah, what temperature it's been
Yeah.
stored at, the whole lot.
which the world's coming into a lot more healthy eating, more organic, and people want to know where their food is, and that blockchain
and
is
ethical
verifies
sourcing
it
as
to
well.
The
the
other-
consumer.
Sorry, the other really big thing that helps with this is not only just tracking that back for anything that may have had an issue or recalls or knowing, but it's fraud. There's,
And even if it is a private permissioned ledger,
Yes.
like no one person or two person can go in and change all the
Yeah.
Records.
settings, you can say.
Ah, okay,
Yeah.
settings, yes.
Yeah,
Okay.
yeah.
depending on the
Yeah.
time, yeah.
Alrighty. So because like when we, by the way, I like having fish born with QR codes.
Well, they're not born
Yeah.
with QR codes.
They're tagged and
They
packaged.
catch them, and as they're hauled onto the boat,
Yeah.
they're tagged. That tag then stores information. So we're talking IoT devices here.
IoT device. So
Yeah.
so are we saying that so there's a massive possibility to connect the IoT to the blockchain?
Absolutely.
Yeah.
Like what?
Well, that's all right. We'll use the fish as an example. The
Yes.
fish gets tagged as it gets pulled onto the boat.
Yes.
Okay. There will be IoT devices in the freezer or refrigerator compartments on the boat, so that you know what temperature it's caught at.
Yeah.
GPS coordinates, so you know where it's caught, which boat, who owns that boat, that type of stuff.
Yes.
And then as it comes down through the processing process,
Yes.
manufacturing, well, it's not manufacturing, but processing, and as it gets cut up, so it might then be packaged into smaller things that will then contain the
Another
QR
QR,
code,
a different
on-
one or-
a different one on
yeah.
that that will reference back to that previous one, so that you can trace it the entire way back,
Okay.
and that way, I know that it's a lot of transparency for these companies to sort of give up to the consumers,
Yes.
but that instills trust.
Okay.
And with transparency comes accountability.
Accountability. That's
So,
huge, right?
so you know that's been, well, they're not going to tell you that they went and ripped some dodgy looking eel out of a creek and tried to tell you that it was some nice type of fish.
Yeah. Like tuna.
Because the entire thing was traced back. But that's the thing. There's like, I'm sure it depends on the fish species and which country.
Yes.
But it's up to 80% of the fish that you buy
Yes.
isn't what it actually
It's in what
is.
it is.
Yeah.
And that's scary when you think
Yeah.
about it, right? And so so Maureen, like when we talk about this technology and it sounds cool and and not many then people will be like, okay, this is like really cool tech, but whatever it is, they hear what we are saying is like immutable, that means they can't edit it, right? And people get scared, like, oh, what if I put the wrong number in it?
Yeah.
Now I can't edit it. What happens then? Because for example, like the temperature gauges, right? We spoke about the temperature gauges, and what if there's a problem with the temperature gauge and they fix it? So what happens to that record? Does it mean that what happens? That's like false information that goes on chain. So what do you guys think of that?
Well, I mean, when it comes to supply, and see, that's a really good question, because a lot of these things are what you'd say at the concept stage. So everything on paper sounds great. Like everyone wants to use new technology for so many things. But what you'll find is sometimes when it's like over-regulating,
Yes.
when you put too much stuff in, the things outside of it can control the whole thing. So you could lose a big multi-million-dollar contract because of human error, or the people that put the information in, or like, a faulty temperature setting. So what they've started to do with things like supply chains
Yes.
is actually have, multi-signature things, like, so oracles, outside oracles that add to the database, or people that confirm, if they have 2 out of the 3 people agree that yes, that was right or it wasn't,
Yes.
you can override it. So there's a lot of safeguards that you can put in place.
Okay.
So
Makes sense.
you don't,
Yeah.
yeah. So I think as this technology develops and as people have more use cases for it, they're understanding that you can't necessarily leave everything up to technology. You have to, plan for error. You have to plan for the things that could go wrong.
Yeah.
So yeah,
All right.
and that's where the concept of oracles comes in,
Yeah.
or like, outside agreeing and stuff.
And it can be built into the smarts of what it is you're tracking as well.
Yeah.
Okay, so if you have a temperature sensor,
Yeah.
and it says, it's 45 degrees
Yes.
where the seafood is being stored,
Exactly, yeah.
45 degrees Celsius, and that's on the boat.
Yeah.
But that boat is hauling crabs from the sea floor of the Bering Sea.
Yes.
There's no way known it's 45 degrees there, I can tell you that
Yeah.
right now. So there would be like a particular range that it should operate within, and if it's outside of that, then it would certainly alert. But again, they do it with multiple sensors.
Yes.
You might
Yeah.
have 3 temperature sensors, so it's got its own little consensus mechanism.
Yeah.
Yeah.
And either all 3 or at least 2 of the 3 have to agree on what it is
Yeah.
before that data is written to the blockchain.
Okay. Cool. I think earlier, thank you for that, guys. If we're going to talk about like transaction fees a bit. I just want to go back to the transaction fees, right? So when someone pays, when I buy my NFTs, I had to keep on paying this transaction fee every single time. Who am I paying to? Is it going to a Steve, or who gets that transaction fee? What happens to that?
If
Well, I
Steve's
guess
the
it-
miner,
I guess it also depends what network you're
that's
on,
right.
Yeah.
Yeah.
what blockchain you're using.
Let's start with Ethereum.
So Ethereum, again, at the moment,
Uh-huh.
you're paying the miners.
Yeah.
with,
At the moment, it's like today. What's
proof
today?
of work.
Today's what? 30.
Yeah.
31st of
31st of
August.
August.
So at the moment, you're paying the miners to use their GPUs and hardware to validate that transaction and send it to the blockchain. Coming within the next month,
Yeah.
they'll have proof of stake, which is actually people in the community locking their tokens up. You got to have 32 Ethereum. You lock that up, and then you become a validator node with your 32 Ethereum. And
Yes.
you're pretty much supplying liquidity to the network with
I
those
see.
32
Yeah.
tokens, which we'll see how that goes. But they're saying fees will come down, so you won't pay so much for your
Yes,
NFTs
finally.
to come. And it's a bit interesting there with triple happening and stuff, but
Yes.
we won't get into that today.
Yeah.
But yeah, there's pretty much proof of work using hardware
Yes.
to do it, and people are paying electricity, crunching numbers, battling everyone else to solve the riddle and the
Yes.
algorithm before anyone else. Proof of stake, you'll be locking up a certain amount of tokens to have a stake in the network and use that as liquidity to provide. And then there's also, as we touched base on, authority of proof of stake, where
Yes.
normally for some reason, I don't know why, but in crypto you see 21
Yes.
validators.
Yeah.
So they've got a huge stake, they've got a lot of tokens, they've got a lot of interest in the network. So they're staking, they're providing transactions, they're getting paid for all the mining fees,
Yes.
but they're also incentivized not to crash or
I see.
change
Yes.
the network, as we touched on before, change the network
Yes.
because they've got their own stake in that
Makes
network,
sense.
so they want
Yeah.
to do the best
Yeah.
for that actual blockchain. And then also delegated proof of stake, where I hold X amount of tokens, we all hold X amount of tokens. We can vote for someone in the community that starts putting themselves forward and let them be a validator
Yeah.
of the network, and that can work with hardware too. I believe EOS was mostly run on AWS servers
Yes.
on there, but I think it's changed now. I haven't looked in a while, but so that's you've still got 21 people validating, which makes the network
That's
a
we're
lot
talking about the
faster.
21 people, the BNB chain, but not Ethereum.
No.
No, Ethereum's got
Like
Yeah.
who knows?
thousands,
Like thousands or millions, who knows, right?
Maybe there's a couple more thousand since we started.
We started,
today.
yes.
So that comes into the triangle, which Craig will touch base on that one.
Okay, so we
A bit
prepare for the
later on.
triangle. All right. Let's talk about the triangles.
Trilemma.
All
The
right.
triangle trilemma.
All right. Let's talk about what is this triangle that is the
And
what
just
do
to
you call-
finalise on that one, so people get paid to validate those networks, and there's a trade-off that we'll talk about now.
Okay, is it the Bermuda Triangle we're talking about?
Almost. People call it a triangle,
Yes.
and it's odd because you really only end up with 2 good sides.
Okay.
Okay, and that's why it's a bit of a dilemma.
Okay.
So we're talking about speed,
Speed.
decentralization,
Yeah.
scalability,
Okay.
or well, speed and scalability,
Yeah.
and security.
That's
right?
all.
No, there's three: speed and scalability.
Okay,
I'm bundling into one here.
Okay, that's cheating.
Well,
Yeah.
no, it isn't. It
They're
isn't really
interchangeable.
because
They can be interchangeable.
because something can be fast but
Yeah.
not scalable, or maybe it has to scale to be fast.
Mm-hmm.
So if I can do 10 transactions a second,
Yeah.
then that's all I'm going to be able to do, unless I scale.
Mm-hmm.
At which point, each one of those can do 10, and
Okay.
we're off to the
All right.
races, which is why the scalability has an impact on speed.
Yeah.
It's the old adage of good, fast, cheap.
Got it.
Pick two.
Yeah. You can't
Okay.
have all three.
So if you ask me to do something for you and
Yes.
you want it good and
Yeah.
you want it cheap,
Yeah, and
it's
fast.
probably going to take a
Oh.
while. That's my point. You're not going to get the speed.
Yeah.
If you want it good and fast, then I need to throw more resources at it, so
Yes.
it's not going to be cheap.
Makes sense. Yeah.
Okay.
Mm-hmm.
It's the way it works. So I mean, security is generally there when we're talking blockchain. I mean,
Yes.
it has its own inbuilt, somewhat security mechanisms. Of course, when we get down to limited number of validators or 21 nodes and things like that, sometimes that's limited or reduced slightly. In most cases, what tends to be missed on the triangle is you'll get the security,
Yes.
you'll get the decentralization,
Yes.
right? And it's quite often the speed or scalability
Yes.
that falls behind, because
falls
nobody wants to use anything that's insecure,
Of course.
right? And the decentralization,
Yes.
depending on whether it's public, private, or Rust,
Yes.
but that also contributes to that security, because the more people that are using it and
Yes.
the further spread out it is,
Of
the
course.
more secure it is. So then generally it's speed
Mm-hmm.
that people end up compromising on, which is why they're looking at things like sharding, layer 2 networks. There's a whole heap of stuff that's probably a little bit too in depth to go into in this particular
Yes.
conversation.
Yep.
But it tends to be the one that's sacrificed over the other two.
Okay. I mean,
Yeah.
sorry, Charlie, you can go ahead.
Oh, no, I was just agreeing, but yeah, and you see a lot of marketing these days of people going, oh, we're super fast, we're super cheap, we're going to be the new blockchain,
Yeah.
we're going to take out Ethereum, but they've traded off on that decentralization
That's
nature
correct.
Yeah.
of what people like about Ethereum itself,
And that's fine depending on the use
on
case.
what the use case
That's
is.
right. It all comes back to the use case
Yeah.
and what the users of that network are happy to put up with.
But a lot of people don't know about the triangle, and they're just like, oh, this is new technology, not knowing
Yeah,
that
well,
there's been a
It's
trade-off
the same one that's
to
faster.
achieve
Yeah.
that.
Makes
that
sense.
goal.
Yeah.
Yeah.
So, we talk about this here, like the 21 validators, right? And then Ethereum being like all these hundreds and thousands of computers and da 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 da.
So
da.
the 21 validators
Yes.
traded off decentralization for speed and
For
security.
speed and security, right? Now, think for
Some not all security.
but
There's
some.
only 21 of them.
Yeah.
Yes.
Yeah.
Yeah.
So-
but they're spread different, I'll call them companies, but they're not companies, but different people, different places in the world,
Yeah.
all around, different computer networks that they're using or stake of their tokens. So
Yeah.
you've got to be able to tackle these different entities to be able to get to them rather it being in the one.
I'm really hoping you're not going to ask a question,
Come
because
on.
it's one that I don't like to answer.
Okay.
Okay, so how many
Yeah.
nodes would you require to be in a blockchain to call it
Yeah.
decentralized?
Decentralized. That's a really good question.
That is,
Because it can be distributed but not decentralized. So,
Correct.
so we're assuming that each node is controlled by a different entity,
Different entity.
in this example.
yeah,
Yes.
yeah.
So and that they're in different geographic locations for the sake of the argument. So,
Yes.
so how many before it's
Like,
decentralized?
Well, we know what centralized is, but I still can't answer what decentralized is. Like we say Bitcoin's decentralized, but the hash rate comes from the 3 major mining pools in the world. So
Yeah.
there's that discussion there, but that's starting to get into the.
I think that's
the transfers. So
actually, you know what?
it's
That's what I was
hard.
going to ask the question. That's the question I was going to ask, right? You're saying like all these are distributed at thousands of computers, but
Yeah.
what if I got a quantum computer
Yeah.
that's more powerful than anyone else and using for mining, right? Then it will be centralized, wouldn't it? But
Basically,
Or
yeah,
it's-
because it's a trade-off for computation power.
It
So
could be
who
a
can
mining
answer
pool.
a complex
Yeah.
mathematical equation first?
so
Or if those free Bitcoin mining pools decide to come together and change the network, they would destroy that and someone would just fork off and carry on.
And that
in
would
the
depend
network.
on what was they were changing as to how many people wanted to come with, how many
Yeah.
didn't.
Which comes
Yeah.
into like
Dilutes
hard
the
forks,
ecosystem.
comes into
Yeah.
hard
Yeah.
forks, which is why we have like a few.
yeah.
Yeah.
So with this, we touch base. We use the word oracle a couple of times, Maureen.
Yeah.
You know, the only place I have heard the oracle before was in Matrix, right? So talk to me. If you guys don't talk about, like, you know, I'll go around the room. Like, if you want to, whoever wants to talk about oracle. So as you mentioned the word first,
Yeah.
I would let you tell me what is an
Okay.
oracle.
So in blockchain and that concept, they use an oracle basically as most of the times as being an off-chain validator or confirmer of information. So sometimes before something happens on-chain, they need to validate or have someone confirm that it's happened and feed that information for something to execute. Like
Okay.
a lot of smart contracts now include validation from an oracle to feed that information in, and it just helps avoid something happening that can't be, go back on or
Yeah.
yeah.
Okay, so Faizin, if we use the example that fish with the QR codes, so that is something happening in real world that needs to go into the blockchain. So are we talking something like that we need an oracle, or is it just like, oh, there's no oracle in that place? Oracle needs in something like this. So if it's a use case, where would we use oracles?
We use oracles anywhere where the smart contract needs to get information from the outside world.
Say like for
So-
sports betting, for example.
Yeah.
Yeah.
So yes, so it needs to get that information from the outside world, and that is what triggers the next
Yeah.
events in the smart contract.
Okay. So who runs the oracles?
Depends what
That is-
the agreement is. So, for example, you say you had a smart, a smart contract for an insurance company,
Yes.
and it was to insure flights. That for anyone that had a flight that was insured, if they missed if the flight was cancelled
Yes.
or delayed by over 2 hours, you could have it connected. The smart contract could be connected to a confirmer on the outside world,
Yes.
where flight information is available publicly
Yep.
and updated live. So if a flight was cancelled, that information could be fed straight back to the smart contract and automatically execute the contract.
Okay. Yeah.
Yeah.
It's just an
And-
example.
and the
the
one-
accounts money is paid back, yes.
Yeah.
Yeah, and
Okay.
the one I really like for oracles is
Yes.
actually Chainlink.
Yes.
So
Chainlink. What's Chainlink?
Chainlink, it's a decentralized oracle. So just say the US dollar, for instance, if
Yes.
you want that fed to a smart contract.
Yeah.
But what they do is you've got to have a bunch of the link tokens, and then you create your own node validating that price data,
Yes.
and then all of us have our own stake in that.
Got it.
And then I say let's just say for the dollar, it's $1.10. You say $1.10, $1.10. Faison says $1.10, and
Yeah,
sorry,
right.
Craig. Craig says $1.50.
Yes.
Of course,
Well,
Craig would.
they will actually remove his stake and kick him out of the system. So you're
Also,
incentivized.
these are penalties.
So there's penalties. So you're incentivized to be truthful and feed the correct data into the blockchain. And I believe there has to be a minimum of about 21 validators to create that oracle.
So it helps get rid of bad actors.
Bad
basically.
actors.
Or
And
even
groups,
something
yeah.
that's just off and not working. You know?
Yeah.
Okay.
Obviously, they wouldn't do it to you straight away, but if there's a certain,
But there'll be a certain
there's a
amount.
certain
Reward will
amount,
be.
the network will automatically remove that out
Yeah.
of feeding it data.
Okay. That's cool. So again, like we spoke about, we spoke about like proof of staking, proof of work, and proof of authority.
Those, yeah.
Those are we just put through into the mix. So Faizin, can you please give us a bit of a breakdown in what that really means. Like, it means like words to me, like proof of work. I mean, I don't know what it is, just like sounds really cool. So if you want to break it down, can you just give a bit of a quick summary on those, like the mainly used, what do they call
Consensus mechanisms.
Consensus mechanisms.
Yeah.
Yeah, please.
Yeah, proof of work. By the word proof, obviously we mean that it's we are proving that we have done something on this.
Yeah.
So proof of work means we have done some work in validating those transactions or solving that puzzle.
Mm-hmm.
So all the GPU and CPU power spent in solving the puzzle is my proof that I have spent my time, energy on solving that puzzle.
Okay.
So that is the proof of work.
Yes.
And that is used in consensus mechanism. Like, okay, you have a proof that you have solved this puzzle. So
Got it.
we taken your validations in. Similarly with proof of stake, like they give a proof by staking their tokens.
Mm-hmm.
And
Staking. What is
becoming a
staking?
validator.
What is staking?
Like to pledge a stake, basically that to validate a transaction, to show that you have a certain amount
Of something.
Yeah.
It's pretty much an easy way to explain it is like when you put your money in a savings account
Yes.
and then the bank for 6 months
Yes.
and you earn a certain amount of interest
Yes.
and then the bank uses that money to lend out to someone else knowing that it's in your
Yes.
super savers account for 6 months.
Yes.
Well, it's the same thing, but with tokens, you're locking them up so other people can use the network
I
through
see.
your tokens,
Yeah.
but you're not locked into a certain time frame within a
And
blockchain.
that also serves as a security purpose, because if you have logged in some ethers or some tokens,
Yes.
that means if you do a bad act in the network, the
Yeah.
tokens that you have staked is lost. They will be locked. They will not be given back to you.
Ah,
So-
okay.
So that means you cannot, even if you have staked the token, you have the right to validate a transaction,
Yes.
but you cannot put in bad data into the network.
Yeah.
I see.
You lose
And
your
the more
deposit.
coins
Yeah,
you
yeah.
have,
It can be that.
so the more coins you have, the more power you have. And generally they say that it's chosen randomly, but it's actually like a weighted algorithm.
Yeah.
So
Okay. Cool.
it's like having skin in the game.
Yeah, skin in the game.
Yeah.
Right?
Yeah.
All right. So we spoke about proof of work. We spoke about proof of stake. What is the other? Like, let's say top three. What is the third one you would pick as the most popular?
Authority, there's
Yeah.
there's one more proof of authority that is
Yes.
used in Hyperledger Fabric most often, but
Okay.
again in Hyperledger Fabric we have got a plugin consensus mechanism. Like we can plug in any consensus mechanism
Oh,
over
wow.
there,
Yeah.
but widely used is proof of authority, where
Yes.
you give authority to some person or persons
Yes.
to endorse or validate your transaction depending on some predefined policies.
Okay.
So
So
they
that-
are authorized, not incentivized.
Yeah.
They are authorized
Yes.
to validate your transactions.
So that's a permission that they're given, hence permission blockchain.
Yeah.
Yes.
Okay. That's cool. So top three, we have proof of stake, we have proof of work, and we got proof of authority. So the last question I have is, we said coins, we said tokens, we said currency. What do you say? Right? I mean, what
you
is
can
it?
you can only have a coin if you have a blockchain.
Is it
That's
coin or
the
currency?
native-
It's the same thing.
Native currency.
Yeah.
Okay, currency. Okay.
Yeah. And then a token is if it's built on top of a blockchain.
Like example.
Like a layer 1, layer 2.
It'd be
I
like
can give an
if you
example. I
Yes.
can give an example. I
Yeah.
always give this example to anyone who asks a difference between these two.
Yeah.
So if, for example, if you're working in a bread company,
Yes.
as an incentive, you will get breads.
Say it again.
right?
You will
Not
get
something else.
bread. Okay.
So in a network like Ethereum or Bitcoin or any other network,
Hmm.
when you mine transactions, obviously you will get incentivized with the native currency,
Yes.
their native currency. So that is what is called,
Currency.
what is called?
The coin.
Yeah. You need some coin? Okay, cool. That's cool. So it's like pretty much what I say, like the token,
native token.
the
of
native
blockchain
token
versus
says
someone who's built
On
on
top.
top of that blockchain their own
Yeah.
mechanism. Like,
SHIB. What is a SHIB?
well, for instance, you've got your coin, which is Ethereum,
Yes.
and you have to pay that for any transactions you do.
Yes.
So when you're creating your smart contract for your SHIBs,
Yes.
so you're creating your tokens called SHIBs, but to release that contract, you've got to pay with your coin to validate that to the miners to get that smart contract.
Which is the
live,
coin is Ethereum.
Which
Yeah.
the coin is Ethereum.
So sometimes they call them layer 1 and layer 2.
Mhm.
I would have went USDT, but I know you guys love SHIBs, so we'll just detail.
Alrighty.
I just want to say ship to $1.
Ship to
Yeah.
$1. Definitely gonna ship to $1.
It only needs to rally like 50 decimal places.
Alright.
Good.
Awesome. So guys, thank you so much for today's podcast. And the Twitter space as well. So what we're going to do is now we're going to do this weekly, and as we mentioned last time, we'll be doing this every Wednesday, 2:00 Eastern Standard Time. Right? And one thing we want to say to everyone is that all of us in this space, anyone says they're experts. I think this, we were experts of yesterday, but not today. Today we are learning. Tomorrow we are learning. Yesterday's, we were experts, right? So one thing is we are super passionate about blockchain/Web3, and what we are saying, we are enthusiasts of blockchain and Web3 than experts, and everyone had this such a huge, vast technology, right? So in a place like that, you can't be an expert of everything. What we're doing is we are learning on each, with each person, and really it's like the early days of the internet, right? And this is what we're doing, and why we are having this podcast, why we are having these spaces is to bring everyone else on this journey. And so we want to tell everyone, like, look, it's a new technology, don't be scared, lean on people who are in love with this technology, and who are in this for the right reasons. If anyone is leading a conversation with with the dollar value, I would say this is like too early to talk about money. I think at the moment, what we should talk about is innovation and building the ecosystem and helping each other to build this. And obviously there is a cost element, but that should be the byproduct of a good project or a good course. So on that note, guys, thank you so much, and we'll see you next week.
And thanks to our special guest, Phasing.
Thanks,
Phasing.
Phasing.
Thank you,
Thanks,
Phasing.
guys.
Thank you, guys.
Thank
Bye.
you. Bye.
Thank you. Bye-bye.
Bye. Thanks for tuning in. We'll see you next week. Same time, same place.
Subscribe.